Okay, well, welcome back to the MVA on Microsoft Blockchain as a Service. We're going to continue on here in our agenda with the DevOps side of blockchains. And so I'm going to kind of walk through some of the key concepts that you need to consider around the DevOps type scenario when you start working with blockchain. How do you actually use these things in the real world as opposed to just talking about the development and maybe the theory behind the scenes? We want to know how do we actually operationalize these things
Right.
and run them in an enterprise. So one of the core things is around how do we actually manage this type of technology. It's a totally different in some cases than we're used to, right? We're used to versioning things. We're used to release management and deploying things in that model. But we got to consider some special things about these type of decentralized applications. We've kind of harped on it in a lot in the earlier modules, but the ability to be immutable, these smart contracts is a key concept. That has to be considered when we're doing code migrations and as we're deploying things up to the blockchain, as you can
Right.
imagine. If the address changes for our blockchain or for our smart contract, we have to make sure our DApp is
Yeah, they're
pointed to the
hard
right one.
linked. Yeah, they're hard linked in.
Yeah. The other thing to consider is that, and this comes up a lot when we start thinking about adding nodes, if we're going to maybe increase the scale of our network or maybe even decrease the scale, we need to think about what's called the genesis block. We haven't talked about this a whole lot yet, but when you start up one of these blockchains, one of the first things you have to do, or the first thing that you're going to have to do when you establish a blockchain is create a genesis block. That genesis block is going to contain the core, basically the root of your blockchain. And it's said that, basically he who controls the Genesis block controls everything. So
Okay.
if you are in control of the actual Genesis block, you can change some certain parameters about that blockchain. In Ethereum, you can change things like gas limits and these different things in there to kind of control, when Derek was mentioning earlier about like lots of storage in a smart contract or really complex logic, you can actually make it so big that it won't execute, right? Because it would require too much gas.
Okay.
So you can kind of put those, that's kind of where you can kind of tweak things.
Twist the knobs to make it efficient.
Exactly. You could say, hey, I don't want really complex code running up here because I'm only running on D2s. And that's the way I want it. I
Right.
don't want people running big things. And I don't want them storing lots of data up here, this kind of thing. You can kind of control that to some extent. The Coinbase is what generates the first block, the first address when we're up there. And we can also have it generate the first accounts for us. Because obviously when we start a blockchain, somebody has to own the first one,
Something. Yeah.
that we get started, and then it's just going to basically spread out as we add more external accounts, as we were talking about,
Okay.
and transfer that around. And when you think about Ether in the private sense, this isn't on the slide, but it's something to consider when you're doing your Genesis block, is that in a private sense, Ether paying for gas and things doesn't matter as much as in the public space, right? We talked about mining and all those things. And typically what we do is actually just give people, we can move Ether around in a private network. So in order for you to use gas, you could say, all my business partners get this much Ether right now. And if they want more, they can come over here to this faucet and get more.
Right, but you can also use the gas limits in your code and on your blockchain to make sure that other development teams that might be injecting into the private chain are only able to consume X amount of resources
Correct.
before they have to come back. So it's a good throttling mechanism in a
Correct.
private blockchain.
Totally makes sense. It's something to consider when you start building these applications out. The keys used to sign the transactions on the blockchain are tied to unique actors, obviously. So when we generate those keys, they're either tied to a device. It could be an IoT device. It could be a human, in many cases, who are actually going to use the system. It could be a proxy. We could do something on the server side and have it actually talking to the blockchain.
Right.
In some cases, we don't necessarily need to expose all of this technology down to the end user, right? They may just see a web application. People talk about dApps all the time and think that it's like some Star Trek thing, that's out there where we're
It
talking
sounds Star
about.
Trekky.
Yeah,
Yeah.
but it's like, no, it could look just like the applications that you're familiar with today.
Okay.
And that's, I think, really the goal, to make it pervasive. I mean, we can't have people. I don't want to have my mom managing her keys, because
Generally
it's going to
not.
be really
No.
hard for her.
So I could create an MVC app in front of a dApp, and the dApp is just more of the middle tier layer. Is that what you're saying?
That's correct.
Okay.
Yeah. So we could do it in that model. So there's different ways to kind of architect and build these things together. And we get into the kind of drawing sessions, the architecture sessions. We'll kind of draw out some of those for you.
Okay.
The release management process obviously has got to take into consideration migrations as well as dependencies. We'll talk a little bit about Truffle. So Truffle is a very popular, mature product out there that does a really good job at saying, hey, if we have nested smart contracts, We'll talk about that again too, but let me just hit on it right now. We actually have a slide to kind of show this. Essentially, from a core concept, if you look at what a developer's doing, if you look at this slide, a developer's sitting down, he's building a smart contract, he's going to deploy it to the blockchain. We've been talking about that, through all these modules. But that's kind of like the really simple use case. That's not really real world. When people start building more complex and real world applications in these, we're decoupling some of the logic inside of there. So now smart contracts have dependencies on other smart contracts.
Okay, so you build this chain, and each different function or each different piece or business case can be its own smart contract, but you also have the ability to have multiple instances of that smart contract depending on what you're trying to accomplish.
That's correct. And you can think about, as Derek mentioned, that maybe like a chain, lack of a better term, but like having all these dependencies between smart contracts. If we change one in the middle, everything that's dependent on that now has to change. So having a tool, a DevOps tool to actually do that for you is really key. Like it really helps when you start getting complex ones. When you're doing 1-2 contracts, yeah, it's easy to maintain.
Right.
But when you get really nested ones and really complex scenarios, it can actually be really hard to figure out like where.
And that's where those hard links come back in. You want to be able to easily manage the hard links or the addresses to all of the smart contracts, particularly in a versioning scenario.
Yep. And there's a couple different frameworks out there, Embark, Truffle, again, we'll talk about them, but those are really popular ones that can do a really good job at this for you. They can actually kind of script around that, and it helps in a DevOps sense. From a smart contract sense, again, we're talking about, and this is just driving home the point of once we create a smart contract and we hash it and we have it up there, it gets invoked. That's a simple use case. When we start decoupling the logic from the data, we mentioned this earlier, this is kind of a key concept. We can build a library, for lack of a better term, of these smart contracts. So once we build the function that does an asset trade, we don't need to rewrite that 100 times because then we're going to make a mistake. It's just software development 101, right? We don't want to keep rewriting the same thing. We're going to make mistakes. The idea is create that in a self-contained like little unit. We can actually reference that and use that in many places. Now we can harden that thing and make sure that it's really good, and then we don't have to worry so much about like a code bug or something causing a problem up here.
That's where a lot of the formal verification comes back, and the efforts underway now to help the code that it gets written to be formally verified so that we know that there aren't little bugs in there where somebody can run off with all of your Ether or all of your Bitcoin. I have this funny comic on my desk that says all the JavaScript that was ever written has already been written, or ever needs to be written has already been written. That's not quite the way it is right now with smart contracts, but you can assume or get the impression that there can be an ecosystem of Solidity contracts out there where you can say, I need to do this. Well, here's the best practice on how to do that. And you can grab that code and work with it and make any changes that you want.
Yeah, and we're actually working with some partners to actually integrate some of their solutions around that, so stay tuned there. But we have some middleware that we're kind of working on to actually provide those services, both formal verification as well as kind of vetted smart contracts in a library type form.
I promise I didn't tee that up on purpose. That was just a cool idea. All right.
So, and this was, I'd thrown a slide in here to talk about the Genesis block. We've kind of hit that over the head, but I just wanted to kind of come back and just touch base on that. From a Genesis perspective, again, it's the root of the blockchain. When you spin new nodes up, you always have to use that same Genesis block. As you spin a new node up, it has to have that same Genesis block.
And it will download the entire chain.
That's correct.
And do all of its math goo to make sure that nothing has been corrupted or changed or malformed. And so if you've played with creating your own nodes, like if you were to download Bitcoin, it can take several hours to several days to get from Genesis all the way up to the current state.
Yeah, and that's a good point, Derek. I mean, this question comes up a lot where people say, well, this sounds great if I have a big computer, a really fast computer, like Derek mentioned. I mean, it could take days, hours, days. What happens if it's my phone?
Or a Raspberry Pi or, something smaller.
So the key concept to remember there is around clients. They have this concept of what's called a light client and a full client. So when you're talking about a full client, you're talking about what Derek was mentioning earlier, where we download the entire history. And that's really safe, right? Because Derek goes and downloads every block that's ever been in the blockchain. Like if you go fire up any of the public, like Mist or any of those for Ethereum, when you fire that thing up, it'll literally pull down everything that's ever happened in Ethereum history. And so people say, oh my God, that's so much data.
Right, it takes forever.
How can I use that? How can I use that on a phone? Well, the idea is, remember, there's a Merkle tree behind this. There's a hash tree, essentially, behind all this. you could basically prune that tree, right? So you could say, take a whole segment of that tree and hash that, and then say, from now on, I just refer to this hash.
Right.
And that will make sure I don't have to pull down all those blocks.
Start from yesterday's block and go forward.
Exactly.
Okay.
Because the volatility here really happens in the blocks that are just getting minted. The right at the head of the blockchain, the first 2 or 3 blocks until the consensus is built, that's where the volatility is. You shouldn't have blocks back at the start of the block changing. If you do, you got a big problem.
Big problem. And that also speaks to how, when you're developing your application, when do you determine that that state is official? And we talk about, the volatility in the first couple of blocks, but right now it's kind of, at 12 confirmations or 12 other nodes saying, yep, that's correct, that's when we say you're good to go.
Yeah, and that's where the concept that Derek mentioned earlier about soft forks. So we have this concept of what's called forks, which essentially you can imagine all these nodes are running the transactions, right? So as the nodes are running them, they're in various states, right? Like Derek's little tree over there of his nodes, maybe they're like all of a sudden they start forking, and when I say forking, they're coming off the main branch. So we were all in sync, and then Derek started processing transactions, and I started processing transactions. At some point, we should come together because we should match. Right. If we don't, that's when we have like a hard fork. Yeah,
that's bad.
So the soft forks will happen all the time, and they should eventually collide back, and it shouldn't be too far back. That's what I'm saying, like 2 or 3 blocks.
Okay. What other things about the general mining do we need to know about?
Yeah, the other thing I would mention there is the preloaded accounts that we talked about. Just making sure those things get loaded up there when you're starting up your Genesis block.
Okay.
But if we move on to some of the off-chain, I wanted to hit on a couple things here about off-chain because we had been talking about this a little bit around storage.
Right.
But I want to kind of drive that concept home because this is a really key consideration when you start building decentralized applications, and it really fits in DevOps because this is other infrastructure you got to manage.
That you got to manage, and from an IT ops perspective, you got the developers writing their code and taking into consideration on-chain versus off-chain. The IT infrastructure guys, which those guys are close to my heart, they have to maintain, whether it be a DocDB or a SQL database or a Mongo or MySQL or whatever. So additional infrastructure is now coming into play beyond just the nodes that you might have in your private blockchain consortium.
Yeah. So just to kind of talk about what are some of these off-chain components that we're talking, the first one would be an oracle. And this term oracle is used in the Ethereum space, and I have a diagram here to kind of show it. And essentially, we mentioned before, the blockchain can't make calls off, right? So it can't call off-chain into a web service or anything. Let's take a typical model where maybe we do need to get some external data. It's a trading application, and we need to get some external data to feed into our smart contract. So the smart contract is going to do all its work as normal. It'll be all transaction-based. We have all the history. Everything's great there. But we need some external data at, let's say, a scheduled interval, maybe every day. So what we do in that case is we have what's called an Oracle service that sits off-chain. Now this thing essentially is just another client that's calling into the blockchain. So he's just going to call into the smart contract and make transactions. He might update the state. So we're storing the state of whatever this rate is that's being updated in the external world. So we could store that as state in the smart contract and have the Oracle just call in there periodically and update that thing. Well, the downside to that obviously is we got to trust that Oracle. What happens if somebody hacks the Oracle and starts injecting bad rates into our system? The smart contract's not going to know. He's just going to take the rate at face value and use it.
So you're saying that I can't call a web service like the Bing APIs to get a stock price, but you are saying that I can have this Oracle. What's the difference between calling off to a web service as opposed to calling off to an Oracle?
You're not calling off. Okay, so that's the key thing. We never have the blockchain call off. We're actually going backwards. We're going back in. So we have a scheduling mechanism that's running on the outside here that says every day at 2 p.m., call this smart contract and update this state with whatever this value is. And we can put logic out there to do whatever we need to there, right? So it works really well. And there's services actually built around this. Oracleize is one of the big ones out there, the partners. And they have a whole system that basically allows it to look like it's actually calling off-chain, but actually what it's doing is making callbacks into the blockchain.
But at the end of the day, an Oracle is still just a node on the network, and it's talking to the chain itself. It's not going web, it's not using SOAP, it's not doing all of those things that I wanted to do previously. Okay.
One thing to consider from a DevOps, to pull this back into the DevOps space, because we're talking a little Devy here, but like from a DevOps sense, what do they need to consider? Well, we got now this external service that's going to make calls into there. Well, that thing's going to have key pairs, obviously, right? Because in order to do a transaction, it has to have a key pair. That key pair can actually be in the smart contract. So we can set up functions that basically, like a getter and a setter, let's say. let's say a setter, just for our use case that we were talking about before. We could inject values into a smart contract. We wouldn't just write directly to the state. We call a set function.
Okay.
In that set function, we can actually put a function modifier. It's called in Solidity, and actually say this can only be called by this oracle.
Oh, okay.
So that way we can kind of
lock it down a little bit. Okay.
And the DevOps guys kind of have to be, obviously in sync with this, because if they change something out there in an external service, the keys don't match, brokered.
Right. Okay. So that's an oracle. You got anything else?
Yeah, from a sense of like looking beyond oracles, this is where Microsoft has been focused a lot of the effort. And if you look out on our GitHub, Marley Gray's been working a lot on this technology called cryptlets. And if you think about cryptlets, there's a lot of different things that these cryptlets can do, but this is really an innovation point that we're trying to bring some of our kind of expertise in this space to fill this void. So we looked at one particular use case of the oracles to say, how could we make that situation better? Well, what's the issue that you have around that right now? The issue you have is that we don't 100% trust that oracle.
Okay.
We could have somebody hack that oracle. We could have other things happen to that oracle. We don't necessarily like that. How could we make that thing much stronger?
Okay.
And so if we looked at what Intel was working on with the SGX stuff, so the secure code execution stuff that they have built there.
This is a hardware thing.
Correct. This is a hardware module. And we said, could we build some strong relationship between that piece of hardware and our blockchain in such a way that we can anchor these attested hosts on the blockchain? So now we know for sure
it's trusted.
It's trusted, basically. And now we have a trusted environment that allows us to do things. So Oracle would obviously be a great use case for this, right? Because now we can trust our Oracle 100%, but you can think that this could go beyond.
Okay, great. And so what other types of patterns do we need to consider here beyond oracles and cryptlets? What other things do we need to consider?
Yeah, I'd say the other big one that we talked about before was storage. So being able to do off-chain storage on here, there's a variety of different models that you can use there. There's things like IPFS, Interplanetary File System, Swarm. There's a bunch of different off-chain vendors that are spinning up around this space to be able to do that. We also have first-party components, as Derek mentioned, DocDB, and we're looking to say, we could use those. And when you think about how do you effectively use those and trust it, it's two different models. You got to think about verification and security. So it's two different things, right? So if we can say, hey, we could take an external data source, it doesn't matter what it is right now, to store data. It could be a SQL database even. That thing can store data for us. It does a good job. We've been using it for 30 plus years.
Right.
So if we use that to actually store our data and sign it, or hash that actually, and inject that back into the blockchain, we can 100% verify if anybody changes that record set that we have out there.
Yep.
So we haven't provided any security with that model. We've just been able to verify it.
Right.
If somebody wants to go tamper with the data, there's nothing to stop them from doing that. They could go in that SQL database and tamper it, but it won't match up to what's on the blockchain. And we can point back to that point in time and say, this is when it changed.
This is when it happened.
Now, if you take
auditors will love that.
If you take that a step further and say, well, we want to do that, plus we want security, we can encrypt it. Right. So we still have our key pairs, so we can use some encryption there to actually do the encryption, and then we can work with certain parties to expose selectively that data.
Very cool. Very cool. Well, that wraps it up for this module. We're going to come back here in the next little bit and talk about the development of the decentralized apps, so stay tuned.